Well, why can't we do the vectors then if we've been learning for a long time? Okay, these are calculator problems. You need a calculator. But you guys are making this way too hard. Okay, shh. I'm trying. Okay, you guys, x of t is the position in the x direction. And then, of course, y of t is the position in the y direction. These are not hard. You will have. It's important to remember you will have either this or a polar or maybe a combination of the two. They could do that. Okay, Bjorn, put your computer away. We're doing this. Then what is x prime of t, which is also dx dt? It's a vector. It's the velocity in the x direction. And we can come back and do more polars today too, but I want to make sure we get the vectors in. Because we didn't do all the polars, but we did all the polars in the study session on Monday night. And then this is y prime of t, which is dy dt, which is the velocity in the y direction. So you're going to need your packets. This doesn't take very long to do. What's the acceleration vector? This always freaks you out. It's just the second derivative. So a sub x is x double prime of t. This is v sub x. This is v sub y. Sorry. That's the acceleration. Now, often they put their answers like this. They don't care. So when you read the scoring rubric, you see that, but it doesn't really matter. And that's equal to y double prime of t. That's the acceleration. So that's pretty easy. Speed. Yep. And we'll go ahead and do arc length while we're here, because it's related. Okay, guys? Okay. How do you find now you can't find a velocity vector where you, I don't know what you want to do with them. It's just the velocity in the x, velocity in the y. Yeah, I'm going to get there. Hey, you guys? Eric? You're not going to be quiet. Okay, here is your vector diagram. This is v sub x, which is dx dt. This is v sub y, which is dy dt. You can find the magnitude of the resultant. That's your speed. But this tells you how fast you're going in the x direction, how fast you're going in the y direction. So if I want to find this, it's just Pythagorean's theorem. It's the square root of v sub x squared plus v sub y squared. That's your speed. So if they ask you for the speed, that's all they're asking you. Don't make it hard. Now, because this is a calculator problem, you could store this information on your calculator. They're not going to clear it. It's the square root of v sub x squared plus v sub y squared. Okay, Ori? How do you find how far you've traveled? Do you remember from 9th grade physics? Distance equals rate times time, right? That's your rate. So how do you find how far you've traveled? Guess what you do with this? You integrate it. That is your arc length. Now, there's one little problem with this. That's from T1 to T2. Let me formally write this out. This is L. So L is equal to the integral from T1 to T2. You're going to have to find the times. They may give you the positions, but not the times. It's the square root of dx dt squared, dx dt squared plus dy dt squared. The problem is, 2 years ago, I think it was, and I graded this one, they were asking for the arc length, but you weren't given dx dt and dy dt, you were given y. And so what you do is you have to know all three forms for arc length. So L is equal to, I'll get the limits of integration in a second, it's the square root of 1 plus dy dx squared times dx. And this is from x1 to x2. If they give you for x in terms of y, then it's this one. And we can find that problem. We're going to start with the first one from 2012. If you are looking at, not x's, if you are thinking you're pressed for time, because I know you guys do a lot of things and everything, well, then start with 2012 and work backwards. And we're going to walk through the 2012 exam before we can do the vector problem. And then this is 1 plus dx dy squared dy. And I remember reading, I graded this, I didn't think it was too bad, but I remember reading the comments on AP Central, and they said students knew this first formula, but they didn't know the other two. So I just did arc length because it fits in with the vector stuff anyway. And it could appear anywhere. Now, if they just ask you for the position in the x direction, we're going to use the fundamental theorem of calculus, or the distance in the y direction. Do you remember what the fundamental theorem of calculus is? Well, we're just going to do part 1. Hopefully, we'll remember part 2. So it's f of b. And I could review that right now. If you want, or we can wait. Okay. So if I want to find the position, I'm given some initial t0, x0. Okay, guys? This is going to come into the AB part and the BC. Okay, Eric? If they want you to find the position at some later time, t and x, then what we do is we integrate from t0 to t of x prime of t. What's the antiderivative of x prime? X of t, evaluated at t0 and t. I mean, this is just the fundamental theorem of calculus, but you will see it in AB. So the integral from t0 to t of x prime of t dt, and we're going to see this in the first problem, is going to be x of t, maybe it's 4, minus x of t0. So when you do these problems, to find where the position is later on, you start, and you can just write this down, with your initial position, plus, and that's the distance you travel. It's the displacement. You should be careful with that. So we're going to do a problem that makes you have to do this. But you will see it, and I'll point it out to you when we go through the 2012 exam. Now, you guys know which ones are the common problems. The AB students don't. And you say, well, how do I know? Well, you do. We're going to go through the exam. And I think that's all you need to know about vectors. Now, these are usually calculator problems. Oh, yeah. Thank you for reminding me. Okay. I forgot that. Dy dx, what is dy dx? It's the slope of the tangent line. A lot of you think that that gives you your velocity. No, or it gives you your speed. No, it doesn't. It's the slope of the tangent line. Doesn't matter. It's the slope of the tangent line to the parametric. So if your parametric looked like that, it would be the slope of the tangent lines. To get the velocity, you have to have the two components. And to get the speed, you must use this formula for speed. Where is that guy? Up a little bit further, right here. This. That's how you get speed. Yeah, it is. dx dt is your rate of change in the x direction. Okay? When you put them together, you can't put them together. All you can find is speed. So, yes. If you want, let's get this first, and then we'll do that, but don't let me forget. This is what? dy dt. This is just like polars, isn't it? It's exactly like polars. Just change t's to thetas. So they might mix those two problems because they like to do that. So then, how do I find my displacement? This is an AB topic. Now, this is not a vector, so let me write that too. Not a vector or a parametric. How do you find your displacement? It's the integral of the velocity dt. Oops, T1 and T2. Sorry. So that's going to give me S of T2 minus S of T1. That's the displacement. How do I find the actual distance we travel? My displacement from walking from my chair over to the wall and then back to the chair is what? 0. So that's just the plain integral. Remember, that's a signed area. But my distance, and last night my feet told me my distance I traveled was not 0. How do you get the distance? That's right. It's the integral, and that will be a calculator problem, unless they said set up and do not integrate. T1 to T2, absolute value of V of t dt. And by the way, you guys can create your own study sessions. There's nothing wrong with that. Just get together at Caribou and go work on problems. Okay? You see the difference between distance and displacement? I think I've got everything for my vectors there. Not a lot of color, but. Okay, ready to try 2012. Yeah. 2012, we're going to walk through the exam first, then we'll do the vector problem. Further? Now, I will save this. I'll call it the vector lesson or something like that for 2012, but you keep, because I just do a big print of the whole exam, you get all of 2012 with that. But it's a PDF, so you can scroll through it quickly. Oh, I don't want that. Okay, we ready? Let's go to the very beginning, which is, of course, there. Okay, question 1. Now, yes. Now, when you're on the exam, I've always seen question 1 as the common problem, but that doesn't mean it is. Well, maybe not always. Sometimes it's the vector. Okay, you guys? You guys? Look at this. Guys? Here's the fundamental theorem of calculus on D. Hey, John. That's the fundamental theorem of calculus. I want to find the temperature at 25, and I know what it is at 20, and this is W prime. What is that equal to? W of 25 minus W of 20. That's how you use the fundamental theorem to find where you are later on, either the position, in this case it's the water, or whatever this was. Because I know what W of 20 is. That was in my table. It was 71. Oh yeah, this was the hot tub that got to be 10,000 degrees. We did get a good laugh out of that. So make sure your answers are reasonable. If in 20 minutes you go from 55 degrees to 71 degrees, at 25 minutes, there's no way you're going to be at 10,000 degrees. Yeah, not in my backyard. Okay, so you would solve for, you guys, this is the hot tub. Okay, guys, you would integrate that function, that W prime over there, from 20 to 25 with your calculator. You can't use a CAS. If you have a CAS, you still have to use a definite integral, because they're going to mark you off if you do it the other way. And then you add 71 to your answer. You can see the answer right down here. It's 71 plus this. That's the fundamental theorem of calculus. You see it over and over again. You know you're going to be tested on it in the AB part. If you looked at this problem, you say, I don't see Euler, I don't see any Taylor. That's an AB problem, right? Then you turn the page and you come to this one. And you recognize it. It is not an AB problem because it's a vector problem, parametrics, whatever you want to call it. So let's do, well, we'll do this problem in a second. Okay, so you got, remember, you have two 100% BC problems. That's one of them. That's where we're going to work on it. Look at that. Is there anything about Euler or L'Hopital's rule or Taylor? I see nothing there. Guess what? That's the other common problem. There are 3 common problems. Okay, Matt? Yes, you did that question last year. If you want to watch, and I don't have it enabled, but well, they will be up on YouTube. I have this problem from the last hour that I just did. I just did it. So if you want to see it done, you can see it done. Now, question 4. We've got 2 common problems, and it says Euler's method. Now, read it carefully. Remember, you only have 2 full BC problems. Let's go on, and we'll come back to this in a second. That one has nothing special. That's an AB problem. Remember the bird problem last year? Two are 100% BCs. Okay? So where's the other 100% BC? Usually it's question 6. And we'll do this next week. Oh no, it's actually easy. Because what's A asking for? The ratio test. Well, we'll review it next week. And then we will do these. And I will, you guys, I'm going to print out a packet that you've already gotten, but I'm going to reprint it with all the problems in it. So that we'll just focus on that. And then I think I might have the multiple choice picked out. So when you go back here, you can see that's 100% AB. So 1 was 100% AB, 2 was vector, 3 was 100% AB, 5 is 100% AB, but you only have 2 100% BCs. So if you look at 4, that's the double bubble problem. No, it's not. It's not bad. This is the AB stuff. Now, it isn't what the AB students see. It's just AB content. They do get a different problem than that. They don't get any of what you see here, but it's just different. Okay, and then it says Euler, and then it says Taylor polynomial. So the AB was worth 5 points, and this is worth 4 points. And that's how they get the 60-40 split, plus the multiple choice. I don't know exactly where it is there, but it's there. Okay, so now you will know when you walk out of that exam which ones the AB students did, and then you also did. They won't know because they don't. Everything's AB. So you can talk to them later, but you know right away which ones they are. Maybe they should have a snowman problem for this year. Yes, you test at the same time. You're scattered all over this building, which makes it really hard for Mrs. Hersman and I to come around and wish you luck. But when we were at the church, it was easy because we were all right there, but not here. It's very hard because some of you are over there, some of you are here. Not fun. Okay, let's do this problem. And I want everybody doing it because it's not hard. This is one of the easiest ones, actually. Okay, I don't know. I got to read the question. First off, I like to look at the numbers that are here. That's x is 1, y is 5. And that's when t equals 2. All parametrics do is tell you when you are where you are. That's the difference. Normally, you know where you are, but you don't know when you're there. Okay? And then I have a dx dt, and I have a dy dt. And you should have your calculators out. And what mode should you be in? Radian. Some of you will want to take derivatives by hand. No, don't do that. Okay, is the horizontal movement, which one do I want? Dx dt, to the left or the right? So I want dx dt. If dx dt is positive, then it's going to the right. I like to justify my answers first. If dx dt, because I know what to look for then, is less than 0, it's going to the left. And we're going to do this at t equals 2. Now, I don't even have to use my calculator. Well, yeah, maybe I do. No, I don't. What's dx dt? It's equal to the square root of, and we're doing this at 2. 2 plus 2 over e to the second power. And you know e, well, anything squared is positive. So it's greater than 0, so it's going to the right. That would give me the point, because I've got that justification here. I think the arrows are sufficient, but if you want to be particular and worry about it, then write it out. Okay, that's it. Oh, and then find the slope of the path of the particle. That's easy too. How do you find the slope of the path? What is that? What are they asking for? dy dx. So it's dy dt over dx dt. I said this is an easy one. So that's equal to, well, x dt is the square root of 4 over e squared. Can I just leave my answer complicated like that? Yeah. Yes. Don't use your calculator unless you really have to. And it's the sine squared of 2, was it? 2. That wasn't so bad. Now, you want to do this and get some confidence here, I think. But let's see. It's 3 points? What do you mean that's it? That's pretty easy. You get nothing. You got 3 points, like you just said. You get 1 point for saying that this is positive with the reason. 1 point for thinking about dy dt over dx dt. You get 1 point for just writing that down. Don't skip steps. No, it would be okay to put in 2. If you want to be safe, I'd probably use my calculator. But then you gotta make sure you're in radian mode. You know, I didn't grade this one, so I don't know how picky they were. If they made you go to the decimal, but the exact answer should be okay. Always 3 decimals. Now, if you go to 2 decimals, because the inspires tend to do that, unless you reset the inspire, that's the problem. You will get marked off 1 time on this problem, and 1 time only. Okay? So if you do it all the way through this problem with 2 decimal places, you only get penalized once. Thank goodness. Okay. Ready for B? Yeah. Oh, what? Yeah, I know, but I don't have room to do it. I'm going to do it over here. Okay, so B, find the x-coordinate of the particle's position at t equals 4. So dx dt is the square root of 2t plus, square root of t plus 2 over e to the t. How do you find the position? It's the integral, right? So this is B. We're going to integrate x prime of t dt. This is the fundamental theorem of calculus. I know where I am when? At 2, and I want to find out where I am at 4. So this is 2, and this is 4. So that's equal to x of 4 minus x of 2. Yes, you will have to integrate this on your calculator. So I can't do that one. Maybe integration by parts to do it by hand. So it's the square root of t plus 2 over e to the t, is that right? dt from 2 to 4, this calculator problem, equals x of 4, and what's x of 2? 1. So you have to add 1 to your answer. Yes, that's why I wrote it, circled it up here, or wrote it down. Right up here. Yeah, when t equals 2, x is 1. 1.253? Well, let's go see. You have to add the 1. Oh, you got it right. 2 points. 1 for setting up the integral with the 1 in there. Well, no, maybe not. They might have just given you a point to say, hey, you knew to integrate. And then add the 1. It's pretty easy, but whatever. So we're halfway through the problem. But do go, why is it plus 1? Because when you solve this equation here to find x of 4 equals this integral 2 to 4 of x prime of t plus the 1. That's your initial starting position. You might get lucky and start at 0, in which case you'll get it right either way. But that's luck. And I've seen it happen, by the way. Okay, so we're at 5 points. Find, oh, there we go. Find the speed of the particle at t equals 4. How do you find the speed? So speed equals, and you guys always try to do dy dx. No, it's not. It's v sub, sorry. It's the square root of v sub x squared plus v sub y squared. At t equals 4, was it? And you may write it just exactly what I did. At t equals 4. So get your calculators out. And I would do all of this in regular Cartesian coordinates. In y1, I would put in, it was the square root of, is it t plus 2? I want to make sure I'm typing it right. T plus 2 over e to the t. And then in y2, and if you want me to do it, I will. This is the sine of t squared. That's the only way your calculator knows how to do that. It doesn't know how to do the sine squared of t. Do you want me to get my calculator out, or are you just going to do it? You should practice. I know we haven't done much with calculators. 1.414. That's the square root of 2. Yeah, it's t equal to 4. So put 4 in here and 4 in there. Could you have an exact answer? Yeah, I could do the square root of 6 over e to the 4th squared plus the sine of 4 squared, and it's the square root of that. That should give me full credit. Yes, thank you. I thought I had it, but I didn't. So what I would do on my calculator is do the square root of, first off, I would take 4 and store it into x. And then I would take y1 squared plus y2 squared. Do you want me to do that with you? Because there's a, not a trick, but there's a certain amount of elegance to doing this if you want to do it the easy way. Do you know how to store numbers into your calculators? Okay. 0.576. Wait, what is it? What's the next number?
Oh, well, it's 0.57. Is it 0.57?
4?
No,
Oh.
no, it's 0.5745 for round up.
Oh, I see. Or 0.574. Both answers are correct. You can round it or you can truncate. It doesn't matter. So let's see. My guess is that's 1 point, but there's more parts to this question. There it is. 1 point for the speed. Is that okay? Yeah, I'd put it in the calculator. I still don't see why. I'll find out this summer, but it'll be too late. So I guess I'd put it in the calculator. And find the acceleration vector at t equals 4. How do you find the acceleration? What's a sub x? It's n derived of what? Don't do it by hand. Of dx dt, which I put in y1, comma x, comma 4. Find the acceleration in the y direction. It's n derived of dy dt at x equals 4. I'm going to stay in the regular mode, so I'm going to use x's instead of t's. And they put it in those little braces, but who cares? See, this one for sure you would have to integrate. You can't set up the integral. Same thing here. You have to find the derivative. So are you guys going to find the derivative? Remember, you only have 15 minutes for these problems. We will, but we got to get the acceleration first. What's the acceleration? Do you want me to use the? Do you want me to get the calculator out, or are you doing it? Griffin, I haven't done this problem. Oh, did you? You should do another one. And by the way, how do you get better at vector problems? Do a whole bunch of them. And I'll tell you the same as I did AB. We will have little summative quizzes unannounced. Anything I've covered is fair game. So I've done polars. I did all the polars, and I'm starting vectors now. No, they just want a sub x and a sub y. Okay, you ready?
Oh, I thought you were.
There it is. And they put in those brackets. Who cares? We don't care. You can write it this way. A sub x equals, actually, this is a nice, easy problem to grade. 0.989.
Oh, yeah.
When in doubt, include all the decimal places because it'll never hurt you. Okay, so how many points? Was that easy? 3 and 2, 5 and 2, 7. I'd have to go to AP Central and see what they did last year. I don't know. So I didn't grade this one. But I don't always pay attention when, well, there's so much to go over at the end. How do you find the distance traveled from 2 to 4? You have to integrate what? Remember how I said the distance? Should I go back? Let's go back one more. I did it. How do you find the distance? Right there. Okay, it's the absolute value of v of t dt. Oops, so too far. How do you find dxt? How do you find the velocity? So this is this d? It's the integral from 2 to 4. It's the arc length. It's the square root of dx dt squared plus dy dt squared, because that's your velocity, right? That's your speed, dt. That's all it is. Let's see what we got. The square root is an absolute value. Square root's always positive. It's the velocity. There's your velocity in parametric form. I don't need the absolute value. If I want to know how far it went in the x direction and x was the sine of t, then I need the absolute value. Then that will be a calculator. It's all calculator. Not too bad. Yes. No. It's not the integral of dy dx. It's the integral of v sub x squared plus v sub y squared. It's the speed. Remember, that's the speed. To find distance, find displacement, and I integrate dx dt and dy dt separately. dy dx is the slope of the tangent line. That's all it is. I know you guys want to put it in here someplace. So your assignment tonight is to go back and do 2011, 2010, 2009. 2008 was a polar. If you haven't done it, I think we did it. But to do those problems and then check your answers. I can't do it for you. You guys have to do it. Why do you think I'm good at these? I've only done this problem twice now, but I've done all the other ones many times over. So now when I look at it, I go, oh, it's just like the last one. I think 2011 was a little bit harder. And you guys probably want to see your tests. So I'm going to stop here. Now I'm here after school.